What's going on, guys? If you clicked on this video, you're probably wondering how to program an FRC robot um, using WPILib. So this tutorial series will be completely in Java. If you want to use C++, you can, but would not recommend because I think if you're a beginner, Java is more intuitive, and honestly, there's really no reason to use C++. I just don't like C++, if I'm being honest. But anyways, so quick introduction. My name's MJ. I'm the co-captain and programming lead of the Hitchhikers FRC Team 2059, located in Apex, North Carolina. So without further ado, let's get straight into it. Alright, so a quick disclaimer before we actually get into any programming, um, it's important to have a high level understanding of how WPILib works and all the components to your robot and how they're gonna interact with each other, right? So yeah, let's get started. So the first thing to understand is the tech stack, which is just basically a fancy word for on a very high level, what's going on with when you're programming things and up to the moment where you actually um, export your code or deploy your code to your actual robot. So it all starts with the WPILib library, as you can see. Well, it actually starts on your laptop, but your laptop runs WPILib, which can be run on Java or C++. Depends on which language you prefer. Like I said, Java's the way to go with this tutorial series at least, but you can use C++. A lot of these concepts will be the same, but if you're trying to follow along with this video, use Java. So the other thing to know is you're going to pick an IDE. You can use other IDEs besides VSCode, but I would recommend VSCode. It's open source, it's free, it has everything you need, and most importantly, it's lightweight and it's pretty quick in my opinion. I know some people who use what's it called, IntelliJ by JetBrains, but that's for more advanced users, and you honestly don't need it, or you don't need to pay for it either, because honestly, VS Code gets the job done. So once you're programming in your IDE with WPILib and you're ready to deploy your code, it'll go to something called the RoboRio. The RoboRio is essentially, think about it like every computer has a motherboard, so your robot also has a motherboard, and that's called the RoboRio, and that is essentially like the brains of your robot. I like to think of it, right? So your RoboRio connects with the driver station, which in competition is what you see all your cameras with and what you connect your controllers in. So basically, it has human input, joysticks, buttons, switches, etc. And your RoboRio also controls all your motors, pneumatics, solenoids, um, and pretty much everything that you need your robot to do is going to be controlled by the RoboRio. So it's very important to understand how the RoboRio works and how WPILib actually interacts with the RoboRio. So yeah, that's just a quick basic rundown of the high level overview of how things are working under the hood. So let's get into what WPILib actually is. So this is basically just a tree diagram that shows you all that WPILib has to offer. So with the Java version of WPILib, this all goes the same pretty much for the C++ version. Just for the tutorial's sake, since we're using Java, I'm gonna have everything geared towards just Java. So um, basically, you can control and get input from the various actuators and sensors. So there's a difference, right? So sensors, as the name implies, sense things, right? So cameras, limelights, these are all part of your vision systems, right? And a camera, you can do vision processing, train neural networks and deep learning models, to identify objects on the field or other field elements, right? That's more advanced stuff, but the gist is, there's many different kinds of sensors, right? You have gyroscopes, you have encoders, which are basically just used to measure the distance traveled of something like a drivetrain, right? So encoders are usually plugged into motors, and they count the amount of rotations a shaft has in that motor to be able to convert it into a usable number in your code, right? And a gyroscope, basically, you can see how far in degrees you've turned to the left or right, or that's really helpful when you're doing things like autonomous path following. So then on the other side of that, there's actuators, right? And you can control your actuators, right? So in your code, you're gonna have different objects, right? Think of object-oriented programming. People say Java is an object-oriented programming. Well, what does that actually mean? That means that, in your code, you're gonna have objects of these actuators, right? You're gonna have motor objects, right? So you can have many different kinds of motors. You can have Victors, Talons, Neos, right? So it doesn't really matter. You don't need to have all of the same kind of motors for your code to work. You can have one Talon, one Neo, 10 Talons, 10 Jaguars. Doesn't even matter. That's a great thing about WPILib, right? Because it's so versatile. You can use whatever configuration you have, and kind of make it adaptable to whatever you need to make it work, right? And then you also have pneumatics, right? If you're using pneumatics and solenoids, for maybe an intake system, right? And how do you actually control these actuators, right? So you can control them with a joystick or a gamepad, which WPILib has um, built-in method calls, for you to do things like that. And there's basically just a whole lot of stuff that is included in the WPILib library, and it's quite daunting, parsing through all of it. But that's why I'm here, and once you kind of get the hang of it, it's really not that bad. So yeah. All right, guys. So now we're actually ready to install WPILib. Go to this link in the description, and just basically click this little GitHub link, and this will launch you to the 4.1 release, which is the latest. Scroll all the way down, depending on what platform you are on. If you're on Mac or Linux, click these. If you're on Windows, click one of these. I'm on 64-bit, so I installed this one. And once you have it installed, you should see this little ISO file. And what you're going to want to do is you're going to want to open it up. Or actually, you can, I'm going to open it with WinRAR. And you're going to see all these files. And all you got to do is create a new folder, preferably on your desktop or anywhere that's convenient, and just type in, oh, why did my desktop go black? Not sure. Oh well. Just type in WPILib or whatever, and then just click all of these and just drag them in there, and it'll do its thing. Yeah, my desktop does something weird sometimes, where like it just kind of goes black. Not sure why that happens, but anyways, when that's done, click your WPILib folder, and the main thing is going to be this. It's this WPILib installer exe. It's an application, and you're going to right click it and run it as administrator. You probably can't see anything, but because it prompted me for admin, and you'll see this. Press start, and then press everything, and then install for this user, and then you're going to want to use VSCode. That is WPIlib's version, not just VSCode from online, because there's some licensing issue, not sure. So just press download for this computer only, and press next. And additionally, before you run this installer, you might get an error, and that might be because of an antivirus issue. So disable all your antivirus shields. So if you have like Avast or Malwarebytes, it would be a good idea to disable them temporarily. Otherwise, it won't work as expected. So just wait, and it should download. And the other thing is, if you guys need like directions like online, you can just click here. I'll just leave this open. And you can pretty much see on their website everything. They show you step by step how to install everything. Don't worry about all this. This is just WPILib doing its thing. Yeah, so if you have troubleshooting, it'll basically just you can ask the FRC Discord as well. They're pretty helpful. But yeah, it says finish installing. Press finish to exit. And I'll just click out of these. And you can just go ahead and delete this folder. And so you'll see this showed up. There's duplicates here because I already installed this before, so I'll just delete these two. But yeah, you should see these two. And these two folders, this documentation folder will just, if you click it, it'll prompt you to WPIlib's documentation. So yeah, this is just the website for pretty much everything you possibly need help with. So this is pretty useful. And additionally, though, this is the important folder. They'll have these WPILib tools. Don't really worry about anything for right now. The important one is gonna be that we're gonna use later. We're gonna use this thing called sysid for autonomous stuff, but don't really worry about it for right now. And also shuffleboard is also an important one. Um, but yeah, anyways, so in your start menu, you should be able to type in 2022 WPILib VSCode, and you'll see this little thing right here. You can just press open file location, and it'll be right here. You can just Control C, and then Control V. And I've already done all this, but I'll just press replace. And yeah, so this is the VS Code version that you're going to want to use. Alright guys, so now we're actually ready to launch VS Code, so just double click it. You'll see this. And you'll see on the top right, there's this little icon, this little command palette. Just click that, and you'll see all these different options. Additionally, if you just, let's say this is what you see when you launch VS Code and you don't see anything on the top right, don't panic. That's our team slogan, don't panic. Just press, if you're on Windows, Control Shift P, or if you're on Mac, press Command Shift P, and basically all that is it'll launch the command palette, and you can basically see all these different things. But yeah, so just type in create a new project, and you'll see this little WPILib option, and press enter, and then yeah, you'll see it reappeared. But yeah, if you just click it here, you'll basically see all the functionality with WPILib. Once you're here, just press select a project type. For this purpose, this tutorial purpose, we're going to press template, Java, and then command robot. And usually, even if you're not following this tutorial, if you're just like, if you already know all this and you're trying to program your robot, in most scenarios, in like during build season, and you're going to want to use the command robot framework, because that's the most intuitive and straightforward one to use. There's really no reason to use any of these other ones. I know some people use the timed robots framework, but just stick to command robot for right now. Once you're done with that, just select your directory. I'll just put it here. That doesn't really matter, and I'll just call this project name tutorial. And you're gonna want to press create a new folder, and here you're gonna want to enter your team number. Now, the reason this is important, and the reason you cannot mess this up, you need to enter your team number, not just any team number. And the reason is has to do with your radio on your robot. So I'll just drag this in. This will also be in the description. So when you're actually trying to deploy your code, one of the most important things is programming your radio. So there's this little FRC radio configuration tool that you're going to want to use. And if you already haven't programmed your radio on your robot, I highly suggest you do that. And the good thing is all the steps are here, so I don't really need to go through that. But yeah, you see in this little box here, when in the application, you can enter your team number, and you're going to want to enter your team number. So I've already done that, and on my radio, I've entered team 2059. So basically the reason that's important is right here. So you see the DHCP server is, when it's enabled, your radio's address will basically be 10 dot the first digit, the second digit dot the third digit, and then the fourth digit dot 1111. Basically, the only thing that matters here are these 4 characters. So T would correspond to one digit, E would correspond to another. So for me, since it's 2059, it would be 10.20.59. So yeah, that's really important. So just make sure that you have that, otherwise you won't be able to deploy your code to your robot. And this little last checkbox right here is enabling desktop support. You don't really need to worry about that since we're not really doing any simulation. So don't worry about that right now. Let me just move this up really quick. So you should be able to see generate project now, and just press that. And you should see project successfully created, and just press yes. And just press trust all authors. And you'll see all this happening now all of a sudden. You'll see your terminal just open up and it's doing something. Basically, this is just executing a Gradle build. And Gradle is just basically a general purpose build tool that allows you to build any software because it doesn't really make any assumptions of what you're trying to build or how your software is working. So it's really good for WPILib. So just be patient. It might take some time depending on how fast your computer is and whatnot. So just be patient here. It'll just do everything it needs to do. Um, it's gonna do a bunch of crazy stuff. Just you don't really need to worry about it. Um, so in the meantime, actually, you'll see all these folders, right? So you don't need to worry about any of these folders except for source and vendor deps. I'll explain what vendor deps is in a little bit, but for right now, just forget about it. In your source folder, you'll see these two folders. You'll see deploy and Java. Don't worry about deploy. I'll explain what that is later. But the main one is going to be Java. This is where all your code is stored, okay? And you'll see you have two folders underneath that. You have one called command and one called subsystems. Now, why is there a warning here? Let's see. Okay, oh well, it's just not used. No worries. So you'll see they've created one example command and one example subsystem for us already. So basically, to understand what all of this is, also our Gradle build executed successfully. So to understand what all of this is, we're gonna want to head over to this little tree diagram I created. So we basically want to understand how everything's working on a high level, right? So I made this little diagram that represents the command-based robot framework. So imagine this is you, and you're tethered to your RoboRio via USB, and you deploy your code, all right? So what happens, right? Sequentially speaking, this is pretty much what's going on behind the scenes. Now, it may look complicated, but it's pretty straightforward, actually, right? So what first happens is this main method is called, right? So let's go back to VSCode and press this little main.java. So you'll see this little method right here, this little special method in Java to run your code. It's always going to be main. It's going to go, public static void main string args. If you program in Java, this is basically pretty standard. All right, so this main method is called. This is the very first thing that is called. Whatever is inside here is called, right? So when this main method is called, in this main.java file, right, that we're in right here, this is automatically called by the RoboRio. So you don't need to touch this class at all because the RoboRio handles all of it for you. This robot-based.java basically instantiates a robot class for us, that holds all of our components. And this little start robot method is called. So in a robot base, right, this is an abstract class, which basically, and if you don't have any experience with inheritance, an abstract class is just a class that it cannot be instantiated, but it can be subclassed, right? So that's basically what we're doing here. We're calling it here, and if we go to the definition here, we'll see that it has all this stuff written for us, but the method it's calling is called start robot, and start robot is literally starting the robot, right? This is the method, and if there's an error, it'll say fail to initialize terminating, right? So that's just basically what this whole file is doing. You don't need to worry about it. Now let's go to what happens next. So next, what happens is our robot.java file is executed. So this is a file that continuously, the behavior in this robot.java method will continuously loop until the RoboRio is off, as you see. So very little robot logic should actually be written in this class file, because this is just responsible for the main control flow of your robot code, right? So there's a new robot. And what happens when there's a new robot object, right? So let's go to robot.java, and you'll see that this extends a timed robot. So I told you not to use the timed robot template earlier, but in a command-based robot, the way your robot, like the RoboRio, executes your program is in the timed robot framework, right? Because the timed robot framework is essentially just a step-by-step organization of all the different states of your robot, right? So the very first is robot init. This is first called after your start robot method is called, which just creates a new robot object. So after your start robot method is called, it'll go to robot init, or this file, robot.java, and this will instantiate a robot container, right? This performs your button bindings and puts your autonomous chooser on the dashboard. It'll basically this robot container right here is basically the brains of your robot, right? This contains all of your commands and your subsystems, and I'll explain what those are. But it'll contain your button bindings and whatever you want in autonomous. So basically, all the heavy lifting is done in the robot container, right? And this little file right here is just calling that. It's just creating an instance of your robot container. And so it'll initialize the robot, and then it'll do a bunch of other stuff in between, right? So you'll see you have robot periodic, which will basically is the next method it's called, right? Robot periodic will schedule the command scheduler. And what happens here is this little class called the command scheduler. It uses this new robot container, and it'll basically, if we see this command, let me see. Go to definition, you'll see this is the command scheduler class, which is another class that's it's another abstract class that's already written for us. And it's actually an interface because it's implementing these two behaviors. So it'll have all of this stuff already written for us, which is good because the command scheduler is essentially the behind the scenes of how WPILib is handling the order in which your methods are executed, right? So that will basically just run the command scheduler. You can see it pulls buttons, adding newly scheduled commands. This is just basically running periodically because you want the command scheduler to know what you want it to do every 20 milliseconds. Periodic methods like here, periodic, robot periodic, and autonomous periodic execute every 20 milliseconds. So robot periodic will execute every 20 milliseconds regardless of whether you're an autonomous or teleop. Robot periodic is essentially every 20 milliseconds in this block of code, I want the robot to do something, right? Regardless of whether I'm in teleop or autonomous. Okay? Pretty straightforward. Then this is where all the interesting stuff happens, right? This is where this is where we write the code, right? So in the robot container .java, this little file right here, this little class, basically this is where the bulk of our robot should be declared, right? So button and commands and bindings and subsystems. This holds our subsystems, which are actuators, right? That term actuator is basically something, a physical component that is what actually allows our robot to do something. And a command is an action, right? So the difference between that is that a subsystem would house like motors and sensors and whatnot, right? You can have methods in your subsystem to retrieve data and whatnot, but a command will actually actuate your actuators. So it might sound kind of confusing, but think about it like this, right? Let's say I have a Nerf gun, okay? Let's say I have a Nerf gun class, and let's say I want to shoot the Nerf gun, right? So one of the commands would be shoot Nerf gun, and the subsystem that the command is called upon would be called Nerf gun, right? So that's just basically an easy way to think about it, right? You'll see here that in our subsystem you have one example subsystem and another command already made for you. I'll just drag in my code from earlier. So you'll see you have subsystem and commands. These are pretty much, it looks really confusing and whatnot, but let's say I want to shoot using vision. So this is basically command to shoot with vision. Or let's say I want to tilt my climber. So this will tilt it. This is the method. This is the class that I call. This is a command, right? So this is what actually actuates your subsystems, your objects and subsystems. Now, in a subsystem, you'll see that like for extending, right? I have two motors to extend my climbing, right? So I have a can motor and then another can motor. So I'm declaring my motors here, and then in the robot container over here, I'm basically just creating instances of all of my subsystems, right? Another thing is you don't actually need to create instances of your commands here, because what you can do is you can just import them from your source folder. So it'll automatically know. But good idea to instantiate everything here, because these are your subsystem objects that you're going to be operating behavior on. Anyways, so let's go back here. So let's see here, right? So you see in the subsystem, let's say I have a drivetrain subsystem. So this drivetrain subsystem will contain motors, and maybe it might contain an encoder and a gyroscope. Let's say I have a command, right? Let's say I want to lift my collector. So I could have lift collector command, right? And then I could have joystick buttons, right? So like maybe like a Logitech controller or an Xbox controller or whatnot. And you know, the last thing is this constants.java file. This holds port numbers and other variables that will be used conveniently out throughout the code. Because right, if you're thinking about it, when you're working on a large scale project like programming a robot, you would have variables that you don't want to keep retyping them. Or let's say the electrical team changes the port that one of your motors is plugged into. Now, if you're calling the port index maybe like a couple of hundred times, or not 100 times, maybe like you have it, you're referencing this number 5 or 6 times around your code. It would be really annoying to have to go through each class and each Java file and actually search for it and see okay, one of my motors is on port 5 but now it's been changed to port 7. Now you have to go through 5 different files and change it manually. So what we would do is, let me just drag this over here. I have this constants.java file, and don't worry about this gains.java file. That's something separate. But like, let's go here, for example, drive constants, right? This is it's not a good idea to have classes inside of a class, but for the constants file, it's fine because this serves our functionality because we have different classes for different states like auto and drive for our drive subsystem. So right, I have 4 CANSPARK maxes on my drive based subsystem, right? So this is the idea of all of them, and I'm referencing them in my drivetrain right here, right? Drive constants dot left CANSPARK max ID, right? So let's say someone changes that electrically on the Roborio, all right? So I could literally just type in like 9, and that change would apply globally throughout the code because I have this separate constants file. So yeah, pretty neat stuff. Nothing too complicated. I'm just here to give you a quick overview of how things work on a high level. So yeah. Oh yeah, and really quick, this is just tools that you have with VS Code through WPILib. So if you go here in VS Code, you'll see if you type in tools, you just press start tool, and you'll see all of these things, right? So let's say I press enter on sysid. This is the thing I said we'd be using for autonomous path following. Basically, you would connect your robot and put your team IP there, and you'd select all these settings, and you'll run different tests. These little tests right here, and it'll give you data for tuning your autonomous PID control, and it'll give you data and whatnot. So it's pretty helpful. There's also a bunch of other tools, as you can see here. One of them is Pathweaver, which just allows you to visualize trajectories and whatnot, and you can set velocities and acceleration. Another one is the robot simulation tool, which I just showed you. It's used for autonomous PID tuning. So just a quick recap, because I know that was a lot of information. Let's go through a recap. So the main.java file. This is just called by the Roborio at the start. You never call it directly. Don't worry about it. This will do everything it needs to do for us. Now, in the robot.java file, you'll see, this is the primary class that actually gets instantiated, right? So you have the initialize functions and the periodic functions, right? So we understood that an initialize function will just be called once, and a periodic function will be called every 20 milliseconds. Now, feel free to like pause at any time to actually see what's going on. Okay, so the robot.java, right? So initialize is just called once when the robot is started. I shouldn't say motor. Periodic is called every 0.002 seconds or 20 milliseconds to update the commands running on the robot. Pretty straightforward. So depending on the different modes, you'll see, so in autonomous, you'll have these. Teleop, you'll have teleop init, teleop periodic, and then test mode. You don't really need to worry about this. You really don't need anything in this unless you are testing things out, which is a special mode in your what's it called, in your drive station. So there's autonomous, teleop, and then test mode, and there's also a practice mode. You never really use those. It's just autonomous and teleop, so these can be blank. Don't worry about them. So yeah. Now, once again, just a quick differentiation between command-based and time-based. So basically, if you think about it, like I said, in command robot, everything is, structured such that you're heavily relying on inheritance, right? You're going to have one subsystem, one command, and then, you're going to be calling those in your robot container to all interface with each other. A timed robot is more of a procedural way to look at it, right? Because this is a timed robot skeleton, right? Everything is happening sequentially, sequence after sequence after sequence after sequence, right? In the command based, we're just having everything happen through inheritance, right? And the good thing about command based is that we can use the benefits of inheritance alongside with having this procedural class called timed robot, or to basically make everything execute flawlessly and in a manner that is intuitive. So basically, you'll see a subsystem. These are examples of subsystems, right? So like a drivetrain, an elevator, an arm, a ball shooter, and then a command could maybe be like move to scoring position, or drive forward and score, or drive to goal, or elevator to high position, right? So if you think about it, think about a subsystem as the simplest physical component of your robot, right? So subsystems represent lower level hardware, right? The physical hardware, such as motors and pneumatics, as you can see here. And this is just an example of a drivetrain, which contains your motors. And commands represent behavior that is executed on a subsystem. Now, you can have methods that are actuated in a subsystem, and I'll show you that really quickly. So if you go here, let's say in our shooter subsystem, we'll see that we have this method called set index speed, right? So this isn't a command, this is just a method that's directly interfacing with these motors. So basically, I just tell them to get set to a speed. So that's more, maybe you might want to just do that for like very simple things like setting a motor to a certain speed. But with other more complicated commands, it's better to have them in their own command. And yeah, so like I said, this is pretty much just what I said earlier. You write methods to control hardware or read sensor values, right? So like maybe how far an encoder has traveled. And a drivetrain subsystem will have a left motor and a right motor, and maybe you have a method called set speed, which will just make them go to a certain speed. Now command. Think of an action on a motor or a sensor or a group or subsystem of these, right? So the command is initialized, then it's executed, and then it's ended, right? So you see this is called when it's initially scheduled, then this is called while it's executed, and then this happens when it ends. Or basically, there's this method called isFinished, and you can have a condition here such that if it's true, then this command will end, which is why it takes in a Boolean. Now, command groups are a little bit more down the line. I'm not going to really get into them right now. But basically, just think about command groups as, multiple commands happening maybe sequentially or at once, which is called a parallel command group. There's like wait commands and a bunch of other stuff, but, it's not too complicated. Now, joysticks, right? Binding joystick buttons to commands, right? So, well, the essential problem is, right, what do you do when you're not in autonomous mode, right? Because in autonomous mode, you tell your robot to do things autonomously, right? You just tell a sequence of actions and it'll do it. So a button pressed by a human, right? So you want to bind a certain command to this triggering event, right? So let's say you have an Xbox controller. So WPILib has an Xbox controller class, okay? Let's say you have a joystick that looks like this. There's a joystick class, right? So this is just the USB port that it's plugged in on that you can see on the driver station. And basically it'll just create a new joystick object, and you can say, when this button is pressed, I want to do this command. And it's as simple as that. And this is just a little bit more about the command scheduler. I'm not going to go through too in depth because you really don't need to know how it works behind the scenes. You just need to know that it schedules commands in the proper way, and fortunately we don't really have to worry about it. So yeah, I think that's everything. Let's just make sure. Yeah, one more thing. So how do we actually control motors, right? So you have your RoboRio, and it sends a PWM signal, which stands for pulse width modulation. That basically is a way to interface with your motor controller, right? So a PWM signal is basically, it sends voltage, but it doesn't send, let's say you have like a LED and you want to send 5 volts to that LED. Well, it won't send it, all at once, right? Or actually, it would, because it's 5 volts. Let's say you have a 2.5 volt LED, right? You want to send 2.5 volts to this LED. Now, you might think that when you say, send 2.5 volts, it'll just send 2.5 volts constantly. But what actually happens is, for a certain amount of time, it'll send 0 volts, and then for another amount of time, it'll send 5 volts. And over a period of time, the average of that will be 2.5 volts, right? So PWM is basically 0 or 5, and the thing that allows you to go in between, 0 volts and however many volts you need to supply, is this thing called the duty cycle. And duty cycle is just the amount of time where your high voltage is on. So, like, for example, if you're setting between 0 and 5 volts, the amount of time that you're setting 5 volts in each cycle would be called your duty cycle. I'm going through this very fast, I understand, but I'm just trying to give a very basic overview of how everything's working. Don't worry if you don't understand everything either. You don't need to understand everything, especially if you're a beginner. Just know that this is how things work, pretty basic. You can obviously look at other tutorials and, try to understand more what's going on. So yeah, this is just a motor controller, and this will be connected to a motor. This is a sim motor that's displayed, but you'd use a Spark with Neo. And yeah, so once again, really basic. What is a motor? These are motor controllers. So you have Talons, Jaguars, and Victors. There's also Neos that aren't here, so you can see the interface. Now, CAN is just controller area network. It's another way that's really simple to interface with different motor controllers. So yeah. And what is the Roborio? So I've used that term a lot, Roborio, but you might not actually understand what the Roborio is. So the Roborio is just the brain of the robot, which I've already said. Basically, it has a bunch of ports. It has USB ports. It has an I2C bus. It has CAN ports for, wiring. It has PWM for motor controllers. It has an SPI for gyros. A lot of different stuff. So I talked about CAN. So what is CAN? CAN is used to control things like pneumatics, and you can use it for motor controllers. CAN is basically just the most simple way to wire things versus PWM, but sometimes we also use PWM. It just depends on what you're trying to do. And what is a sensor? A sensor, there are many types of sensors, such as cameras and encoders, and if you're using a limelight, which is basically, it shines green light at retroreflective targets to help with things like vision processing. This will be useful for helping understand where your robot is on the field and locating field elements with the camera and whatnot. This is just a quick, Java coding conventions. You can feel free to pause the video and look through these. But yeah, that's pretty much it. I'm glad you guys have stuck this out so far. I know it's pretty boring looking at all of this, but it's important to get the basics down. So rewatch these videos a couple of times. Look at other videos. Go to WPILib's documentation. Really try to understand what's going on. But my feeling is that you won't actually understand what all of this, all of this is until you actually start programming. So don't worry if it doesn't make sense right now. Just try to get a basic understanding of everything that was just said. And thank you guys for watching.